So in this video, I'll explain most important interview questions that was asked for me when I was attending for an interview. The first question is, if we insert custom objects into the HashSet, does it allow duplicates? So here we are trying to add the duplicate objects, right? Will both objects will be inserted or not? That is the question here. So normally HashSet it implements a set interface, it won't allow duplicates. So but here if in a custom objects, it will be work differently. In custom objects, we have to override equals and hash code method. If we are not overridden these two methods, then it will directly use the object class equals method and hash code method. So in object class also we have the equals and hash code method, right? It will equals method will compare the references, not the content, and also hash code also will be generated based on the object reference, not based on the key. So we should override in case of custom objects. But we have one more doubt, in string, integer and all we are using here, we are not manually overriding any methods, right? But in a string and integer and all, by default internally it will implement equals and hash code method. So that's why we don't need to override explicitly. But for custom objects, we have to explicitly override equals hash code method, or else it will use the equals method, equals and hash code methods from the object class. So this is how we have to override equals method and hash code method. So the next question is HashSet versus linked HashSet. So HashSet is both HashSet and linked HashSet will implement a set interface only, and both will not allow any duplicates. And insertion also, in both it will follow the hashing mechanism. Hash code will be generated based on the key, and based on the hash code, and particular bucket index will be calculated, and based on that index it will go to the particular bucket and it will store the data. So by using hashing mechanism only, both will store the data. But the main difference between HashSet and linked HashSet is the insertion order. In HashSet it won't preserve the insertion order, but in linked HashSet it will preserve the insertion order. Why? Because in HashSet we don't have so we are using hashing mechanism, right? It won't preserve any insertion order. But in linked HashSet, along with that hashing, it will internally use as linked list to maintain the insertion order. But here in linked HashSet, it will use internally linked list to maintain the insertion order, right? That's why it will be slow comparing to the HashSet. But mostly we will prefer HashSet only. So because it will the performance also will be improved, and it will be used mostly because of in any cases insertion order is not required and performance is the matters. At that case we will use the HashSet. But in linked HashSet will be used when the insertion order is preserved and performance is okay with the less performance also. At that cases we can use the linked HashSet. So example, we have to fetch the recently searched item or recently visited product, that conditions and all we can implement using linked HashSet. So next question is fail fast and fail safe iterator. So fail fast iterator, fail safe iterator, both will be used to traverse the collection elements one by one. So this is where a fail fast iterator will be created, and we have this is how iterator will be created. We have the two iterators, fail fast and fail safe iterator. So first I'll explain fail fast iterator. So in fail fast iterator, we will be working on the original collection. So that's why if a collection is modified structurally, immediately it will throw the concurrent modification exception. So structural modification in the sense if the collection if we try to add the element or remove the element at the time, so while iterating, if we are adding or removing elements from the collection, immediately it throw the concurrent modification exception. Why? Because it will work on the original collection, not on the clone or a duplicate collection, right? So collections using fail fast iterator like array list, linked list, HashSet, hash map, these and all will use the fail fast iterator. Internally, how fail fast iterator will work, I'll explain. So here we have the collection and iterator, right? In collection, it will maintain internally one variable called mod count. Mod count is nothing but modification count. But in iterator, it will maintain one variable like expected mod count. So normally, whenever the iterator started, mod count value will be inserted into the expected mod count. So whenever the iterator is iterating the collection, if any structural modification has happened to the collection, then mod count value will get changed. So there is a mismatch. Then there is a mismatch will happen between the expected mod count and the mod count. So then immediately it will throw the concurrent modification exception. This is how internally it will work. And coming to failsafe iterator, it won't throw any error exception when the collection is modified during iteration. Also, it won't throw any exception because it won't work on the original collection. It will work on the copy of the collection. So by using copy on write array list and concurrent hash map, we can implement this failsafe iterator. Here example I have shown, like copy on write array list list equal to new copy on write array list. So this will create completely separate copy of the collection object. Okay, it won't work with the original object. So here we are iterating the list, right? So this is like a copy of the separate copy of the collection, not the original collection. Here we are structurally modifying the original collection. So we are iterating copy of the collection and modifying structurally original collection. So both are different, right? Here it won't throw any exception. So that is how it will work. And which one is best, fail fast or fail safe? That we can't say. Like it will work different situations in a different way. So fail fast iterator normally we will use for single threaded applications. If we want to detect the modifications quickly, then we can use this fail fast iterator, because if any single even small modification happen, immediately it will throw the exception, right? So at that cases, if we want to detect accidental modifications quickly, at that case we can use the fail fast iterator. And coming to failsafe iterator, it will be used for the multi-threaded applications. So situations where the modification during iteration needed. Sometimes we have to modify during iteration itself. At that cases and all, we can use the failsafe iterator. So next question is like comparator versus comparable. So comparable is used to define the natural sorting. Like normally comparator and comparable both are interface only used to define the sorting logic. So used to sort the collections, we will using these two interfaces. And comparable is used to define natural sorting. Natural sorting in the sense, if we are trying to sorting the integer values, it will sort automatically in the ascending order. And if you are sorting the string values, it will sort alphabetical manner. So that is the natural sorting. So sorting logic is defined inside the entity class itself in comparable interface. So that is what here, what does that mean? Like this is an entity class. Here inside the entity class itself, we are defining the sorting logic. So that is what that means. Here we are implemented comparable interface because it is an interface. So we have to implement it, and it is present in java.lang package, and it contains the method compare to method. So here we implemented that compare to method only. So we implemented comparable interface. Inside that comparable interface, we have the compare to method, so that we have to overridden and return this our logic. And in comparable, we can define only one sorting logic. So for example, if you want to sort by ID, that one only we can able to do, or sort by name, sort by salary, sort by age. Any one sorting logic only allowed inside the entity class. Okay. So in comparable, only one sorting logic will be allowed. So coming to comparator. So comparator is used to define the custom sorting logic. Though this is the main difference. In comparable, it was like only natural sorting. Here custom sorting logic will be allowed. So sorting logic will be defined outside the entity class. Inside the entity class, we won't define the custom logic as before we defined for the comparable, right? Not like that. And it was present in the java.util package, and it has a compare method. So the main difference is like this is only. So comparable present in the java.lang package, and it has a compare to method. But comparator present in java.util package, it has the compare method. So multiple sorting logics will be possible here. So before in comparable, I told like only one sorting logics will be allowed. That is by age, by salary, or by name. So any one only allowed. But here we can define multiple sorting logics. So in code example I have shown. So here we defined sorting by ID comparator. We've written the logic here, and here also name comparator we have defined, and salary comparator. So we defined multiple sorting logics here. And one more thing, like we are defining the condition here and passing to the collections.sort method. It will do the sorting and all.